Hello chaps and chapettes. Right now there is someone playing basketball outside, so if you can hear that noise, do apologize, but I've got no other time to film this week, so I have to do it now. Today we're going to be looking at series circuits, and what you should know from the end of this video is actually know what a series circuit is, understand how current, resistors and voltage behave in series circuits, and be able to draw a series circuit. Honestly, if you've done the circuit diagram from the last video, you'd know how to do it. It's that very simple thing. The challenge today is to tell me how you can do a Minecraft series circuit using redstone, because I have a little theory on this one. I think every single circuit in Minecraft is actually a series circuit, so it should be kind of straightforward. But I would like to know what you made using circuitry in Minecraft. So let me know in the comment section below. So first we need to look at is knowing what a series circuit is, and that's really straightforward. It's basically all the components in a nice long chain, one after the other. If you want an example of this one or an analogy for it, think like a TV series. In a TV series, all the episodes go one after the other, and so it's the same for a series circuit. So there we go. Now I'm just going to show this to you on the whiteboard in the back of my classroom. So on the way there, hit the like button for the YouTube algorithm, and I'll see you at the back. Right, so what we got here is a setup for a series circuit, and well, not right yet. I'm going to make it right now in front of you. We're not using the power pack today. The reason for that is because I want you to see something about how the series circuit operates when you start adding bits on. So for a series circuit, we need more than one component on there. Now technically, if you do have just a battery and a light bulb, that technically is a series circuit, but it's also technically a parallel circuit. So let's just make things easy. We're going to need two components, and we've got two light bulbs with this one. So what we're going to do is we're going to take some wires. Yeah, we're going to take some wires, and we're going to plug them in to our battery, like so. And there we go. And oh dear, you see we got a black wire going into a black hole there, and a black one there. Got a red wire going to a red hole there, and a red hole there. 1 second. And perfect, there we go. So we got the circuit actually working properly now. Okay, that's going to get confusing. Hang on, let me just take this out then. Oh dear. It's a red wire going into a black hole. It's just not right, it's just not right. Anyway, we have a series circuit here. And what that means is we have two components going in one by one. Now if I just take out one component, you can see that that's nice and bright. If we plug in another one, that's going to make it dark. And that's because of how the voltage and how the current is worked inside one of these series circuits, which we'll come back to as soon as we discuss other things. So there you go, series circuit. So one of the things you need to know how to do is to work out how voltage and resistance work in series circuits. And honestly, it's nice and straightforward. All you need to do is add the potential difference which is dropped across each component. And if you are combining resistors, you just need to add them. So it's nice and straightforward, but I'll show you on the board at the back so you get a good idea. Right, now we're just going to change the voltage on this one to 6 volts. And the reason for that is because it makes the maths a bit easier. And what we need to do is look at how the current operates inside a series circuit. And for that, I'm going to take this ammeter and I'm going to plug it in the middle of those gaps. Okay, so here we go. Setting that to ammeter mode. There we go, 10A. All right. And what we're going to do, put the ammeter here, here, and here. And we're going to see what the current is there, there, and there. And we'll find out what it is. So ammeter goes in, and we find that the current is a negative number, which is not very helpful. Let's just switch that around. There we go. There we go, that's better. And we find that the current is 0.21 amps. Okay, so let's just pop it into here and see if we get any difference. There we go. Circuit on. If anyone's really quick at typing, maybe they can guess in the comment section below as to what this circuit, what the current will be in this next bit. Plug it in, Okay, a negative number again, but never mind. You can see it's 0.2. Okay, 0.2 amps. So basically the same, accounting for various different resistances caused by adding extra wires in. And then going into the last one, switching that around. There we go. Again, see if you can guess in the comment section below, but I think you'll be able to guess what it is. It should be, yeah, about 0.2 again. So 0.2 amps. So from this we can see that current is the same at all points inside our series circuit. 0.2, 0.2, 0.2. Which makes sense because we have this flow of electrons going around, or the current going around, and that is going to be basically the speed of how fast these electrons move. Now you're unlikely to get the electrons going fast here and going slow here, because that would cause like a small electrical traffic jam. You'd end up getting a buildup of charge on one side of the component or one side of the circuit, which you can do, but just not using any of the components we've got here. So in a series circuit, the current should really be the same all the way around. And, well, it is. You can imagine the electrons being on like a big chain and they're all connected to each other. So if one part starts to move quickly, the others will have to move quickly as well. Or you can imagine it as them being like in a long sort of conga line. If one electron starts moving really slowly, then all the ones behind it will have that resistance added on and they will start to move slowly as well. So there you go. That's how current works. Voltage is a little bit different on this one. Okay, so let's just take this out, put that there, and switch this to voltmeter mode. So switching to voltmeter, there we go, plug it in, and there we go. So voltage across here, knowing that these battery packs often lie to us, the voltage across the two terminals is 0. Very easy mistake to make, and that's negative. Don't like negative. There we go. So 5.8 volts across the battery pack, and across this light bulb we will have 2.91, and I'm guessing about the same, 2.95. So basically the same, and you'll find that that number, the voltage across this one and this one, is going to be half that of the battery pack there. If we were to add another light bulb in there, then you can probably guess what happens. The voltage is going to be divided again. So 1.9 and 1.9, and you guessed it, 1.9. Except it's a negative number. Basically 1.9. It's minus 2 on there. Basically 1.9. And what that is showing us is that voltage is shared evenly across our components in a series circuit. So if we have 6 volts across this one, we'll have 2, 2, and 2, provided that the resistance of our components is the same. If resistance changes, then you have to use Ohm's law to work out which one's going to take more of the voltage. But in most cases, higher resistance means that you use more voltage to get across it, so the higher voltage dropped across the component. So there you go in terms of voltage. Now we're thinking about how to combine resistors across this thing. It's really simple. You just add the resistors together. So if this has 2 ohms resistance, and this has 2 ohms resistance, and this has 2 ohms resistance, then the whole thing together will be 6 ohms of resistance. So in series circuits, really easy, just add them together. And there you go. It looks something like this in terms of the maths for it all. So the notation, V total. Actually, you know what? I'll leave this until the second bit once we've done the circuit diagram. All right, so again, one more thing in the back of the classroom, and that's going to be knowing how to draw a series circuit. Honestly, we've done stuff already, but just make sure that you know exactly what you need to do for a series circuit and how you can show the examiner exactly that it is a series circuit and not just like a simple circuit. So hit the like button, join me in the back. Okay, so looking at the circuit diagram for this thing, First of all, we need our battery in there. There we go. Okay. And we need first component, second component. I've actually broken my rules on circuit building on this one. Should really start with the components first and then add in the wires later. It's a good thing I'm on a whiteboard. There we go. So, there we go. That's a series circuit, and it's nice and obviously a series circuit. You don't need to do 3. Just 2 components will be enough to show that this is a series circuit. But we do need to just write down the rules for this thing. If I put I1, I2, I3, and I4, that means the current there, we can say that I1 is equal to I2 is equal to I3 is equal to I4, basically saying that the current is the same at all points in the circuit. Okay? Now, we also need to know the rules of the voltage on this one. V total is going to equal V1, so V1 here, voltage 2 here, voltage 3 here. So the voltage dropped across the bulb there, bulb there, plus V2 plus V3. And there we go. I'm going to switch to a different color just to make this a little bit easier to see. If this has a resistance of R1, and this one R2, and this one R3, then resistance total is going to equal to R1 plus R2 plus R3. And you can just keep stacking things on top of there, likewise with the voltages, and it sure all makes sense. Only thing to point out in this one though, that cell, as far as GCSE is concerned, or that battery, is kicking out V total. So there you go. That's a whole big mess of numbers on there. Make sure you scribble that down and can write it out and reproduce it. And really, it's very important that you remember these 2 bits of formula here. They're not too difficult to remember, but just make sure you remember that you have to add everything together to get the total voltage or the total resistance, and that the current is going to be the same at all points in the circuit. So, there you go. So from that video, you should know what a series circuit is, and you should understand now how current and resistance and voltage works within that circuit. You should also be able to draw a series circuit, and if you've been following on the video so far, it's been really straightforward for you. The challenge today is looking at those Minecraft circuits, and I'm really curious to see what you've done. What redstone contraptions have you made, and, well, what bit of physics did you use to make them? Or what bit of physics did you break to make them? Let me know in the comment section below. Make sure that you subscribe if you haven't done so already so you can get the help if you need it. And make sure that you hit the notification bell so that you can be aware of any new videos that come along that can help you out with doing your homework, or if you want to look at some Star Wars physics or some food physics. And I'll see you in the next video, guys.